All right, let's continue our investigation of radical expressions. Today we're going to talk about multiplying them together. And it's a lot easier than you might think. So you remember that a radical is like a square root or a cube root, some type of a sign that looks like this. The number inside is called a radicand, and this symbol is called the radical symbol. So with that in mind, when you're multiplying radicals, this is where you're multiplying radicals is where you can multiply radical expressions together. Unlike adding radicals, the radicand does not have to be the same in order to multiply the coefficients together. So the steps to multiplying radicals are as follows. First, multiply the coefficients together. Then multiply the radicands together. And then you take the resultant radical and simplify it. For example, if I have 2 times the square root of 2 times 5 times the square root of 3, then I would do 2 times 5, which is 10, and then the square root of 2 times the square root of 3, which is 6, and then I would write the result like that. And that's already as simple as it'll go. Okay, so let's try this one. All right, there's no coefficient that shows up right there in the front of that one. So you basically have 1 square root of 3 times 1 square root of 10. So you don't have to multiply those together. But then you do multiply the square root of 3 times the square root of 10, which comes out to be 3 times 10. Or the final result would be square root of 30. Okay? How about this next one? Again, we have no coefficient, so we just assume there's a 1 there. So then this would just end up being the square root of 2 times 7, which would be the square root of 14. This next one's kind of interesting. You got the square root of 5 times the square root of 5. So if you put them inside the radical together, that's 5 times 5. And if you remember back when we were simplifying them just recently, we got a pair of 5s there. So out comes one of those 5s with nothing left behind. So the actual final answer on this one would just be 5, which is another way of showing that squaring something that is being square rooted, these two things cancel each other out, and you're just left with the number that you had with the start. All right, so let's try this one. We got the square root of 8 times 2, which is the square root of 16. Oh, I happen to know that 16 breaks down into 4 times 4. And so I got a pair of 4s there, so I can take one out of the radical. So take a 4 out of the radical, and there's nothing left behind. So kind of indicate that. So if you take the square root of 4 squared, out comes one of the 4s, and there's your final answer. All right, let's try this one. This is going to be the square root of 3 times 12, which ends up being the square root of 36, which happens to be a perfect square. I know that that's 6 times 6. So I can take one of those 6's outside, and my final answer would just be 6. The square root of 36 is 6. All right, let's look at this next one. We got the square root of 3 times 27, and 3 times 27 happens to be 81. Well, I happen to know from my times tables day that 81 breaks down into 9 times 9. So what we're illustrating here then is the square root of 9 squared equals just plain old 9. All right, here's one that's a little bit bigger. So we've got a 1 out in front of here, so we're going to multiply the coefficients. 1 times 2 is just 2. And then we're going to do the square root of 45 times 75. Now that's a pretty big one, isn't it? So I'm going to grab my calculator and hope you'll do the same. 45 times 75. 45 times 75 is 3,375. So the square root of 3,375. Now the question that might arise is can this be simplified? So I'm going to take the square root of that whole thing and see what I get. And I end up with a pretty crazy decimal. You could divide that by 5, but what would be the point of that? Let's try that. 3,375 divided by 5. Oh, so if I divide this by 5, I get 675. And if I divide that by 5, because it ends in 5, I get 135. Oh, this is looking interesting. We're going to need to extend this page too. So still going here. So 5 times 135. And that ends in 5, so let's break that down into 5. And 135 divided by 5 would be 27. Oh my goodness, look at that. 27. And then we know that, kind of like the number 8, 27 breaks down into 3 times 3 times 3. So 3 threes, right? All right, so I got a pair of 3s. I got a pair of 5s. And that's it. I got a 5 and a 3 left over. So this ends up finally simplifying to be 15 square root of 15. That was kind of an interesting number, wasn't it? Now, we still have that 2 out front, so if we multiply that by 2, we will end up with 30 times the square root of 15. That'll be our final answer. That one took a little bit of work, didn't it? Hopefully we don't have too many like that to work on. Okay, here's another one. The square root of 75 times 4 times the square root of 98. So 1 times 4 would be 4 for our coefficients so far. And then the square root of 75 times 98. So let's do the square root of that after we multiply together. So 75 times 98 is 7350. 7350. Now the question is, could we divide that by 5? Let's see, divide by 5. Yes, we could. If we divide that by 5, we end up with 1470. 1470. Now that ends in That ends in 0, so we could actually divide that by 10 if we wanted to. This would break down into 10 and 147. And 147 you can divide by 3. I need to extend the page a little bit here. So you can divide this one by 3. And 147 divided by 3 would be 49, which in turn comes out to be 7 times 7. So I've got a pair of 7s here. Then up here in my main thing, I got, this also breaks down into 2 times 5. So I got a pair of 5s. So one of those will come out. So out in front of my radical, I'm going to have a 5, a 7 from these two. I'm also going to have a leftover of 3 and 5. And way up at the beginning, I had a starting number of 4. So 4 times 5 is 20. 7 times 20 is 140. And then 3 times 5 is 15, so square root of 15. So that would be our final answer after doing all that work. Okay. But we got a couple more examples to go. So 72 times 4 times the square root of 98. So 72 times 98. These two multiplied together give you the square root of 70, 56. And then that 1 times 4 out front just gives you a 4. And it turns out that 7056, if you do the square root, happens to be 84 times 84. And so I can take one of those out and just do 4 times 84 to get my final answer. So my final answer to this thing is 336. That's simplified all the way as far as it can go, and kind of some unusual techniques there. All right, on our last one, I'm going to do 1 times 4, which is 4. Then we are going to do square root of 98 times the square root of 18. So that's going to be the square root of 98 times 18. Which is 1764. And if we do a square root of that, we get 42. So this turns out to be a perfect square. So the square root of that number in there is 42. So now we just have 4 times 42, which equals 168. All right. So based off of that, we have our Alex assignment. This is multiply radicals, right? And so that's going to be number 77. So let's put that in there. 77. We can just drag that in there and be ready to go. All right, good luck. Thank you very much.